Hi, I'm Teacher Thomas. Welcome to A-Level Mechanics. We're looking at the 2020 specimen paper question 4. A particle of mass 20 kilograms is on a rough plane inclined at an angle of 30 degrees to the horizontal. A force of magnitude 25 newtons acting at an angle of 20 degrees above a line of greatest slope of the plane is used to prevent the particle from sliding down the plane. The coefficient of friction between the particle and the plane is mu. Requirement A, complete the diagram below to show all the forces acting on the particle. Requirement B, find the least possible value of mu. Requirement A, along with the identified pulling force, we have three additional forces. One is the normal force, perpendicular to the plane, identified as R. The other is friction. We're looking at a scenario in which friction is preventing a slide down the plane. So friction is working up the plane. And finally, we have a downward force that is the result of gravity with a mass of 20 kilograms and gravity of 10. We have a force of 200 newtons. For part B, we want the equation friction equals the normal force times coefficient of friction. As our particle is not moving, we're in equilibrium, I'll resolve parallel forces, and then I'll resolve perpendicular forces, and then I'll have values for F and R, which I can use in manipulating the coefficient of friction equation to mu equals F over R. Beginning with parallel forces, two forces are working up the plane, friction and the pulling force of 25 newtons, which is at an angle. I will multiply by cosine of 20 degrees. Those two forces equal the effect of gravity down the plane, which is 20 kilograms times gravity of 10 times sine of 30 degrees. I simplify to F equals 200 sine 30 minus 25 cosine 20. Now resolving perpendicular forces, R is working perpendicular to the plane, as is a component of the 25 Newton force. That component is going to be the sine of 20 degrees. Together these equal the opposite perpendicular force of 200 times cosine 30 degrees. This is the component of the downward force that's working perpendicular to the plane. I simplify to R equals 200 cosine 30 degrees minus 25 sine 20 degrees. And now I can fill in my F and my R to find the value of the coefficient of friction. F 200 sine 30 degrees minus 25 cosine 20 degrees over R 200 cosine 30 degrees minus 25 sine 20 degrees. By using these exact values in numerator and denominator, I'll have a precise answer. My answer is 0.465. This is the least possible value of mu. This completes the requirements for question 4.